So delta LA divided by H for different types of soils, the permissible values are given here. So similarly, LP by H. So passive earth pressure displacement divided by H. So these are the permissible limits. So if the limit is exceeding, then we can able to say the wall deflection may be more and the failure may takes place. Okay. So in order to predict that phi values and depending upon the values phi and the failure mode, so here some concepts are given for active and passive case. So once you have the shear strength principles, so generally just you can see these figures in the textbook, but I don't want to explain that, but I want to specify what is the wrong in the textbook. So some concepts are, some figures are not given correctly. So that's why just I want to explain this. Sigma 1 or just you can expect it from the top, and sigma 3 in the horizontal direction. So once we have this, so here you can see, so sigma z and sigma x, of course, sigma z is sigma 1 and sigma z is sigma x is sigma 3. So once you have these concepts, so the failure may take place from the edge of this, sorry, from the bottom of the retaining wall to top of the ground level. Whatever I have shown here in the previous case, in the, okay, I have to go back here. You can see this failure. So in case of active in case of active pressure, so you can see the failure zone. Here, this is the failure zone. Here, this is passive zone, passive failure zone. So once we have this, what are the different stresses and how it acts? So here you can see the failure lines must be originating from the bottom of the retaining wall and it should extend up to the ground level. So this is the pattern of the failure lines, shear failure plane, whatever failure lanes are failure zones. So this is the failure zone. So here at the bottom, it is almost the angle is starting. Yes, you can see here. This is here. The failure plane is having only one plane here, and here the remaining zone. So the failure lines are extending. Okay. So but here, if you see that passive earth pressure, so in case of passive earth pressure, the failure line is at an angle of 45 minus 5 by 2. In case of active, it is 45 plus 5 by 2. Because there in the previous figure, one figure is there, that's why it's not visible. So here 45 plus 5 by 2 in active case, and in passive case, it is 45 minus 5 by 2. The failure lines are like this. The pattern you can see. So it is originating here and it is extending up to the ground levels. Just you remember this. Then I'll show you the failure lines which are given in our textbooks, which is not correct. Just I'm mentioning that. So here if you see, so the failure lines are shown like this. So here it won't extend at the bottom of the retaining wall. So at the bottom of the retaining wall only, or this just like origin for the generation of the failure lines. So it is not extending in horizontal direction. So here you can see. So it is just like the into marks up to some portion. So this is not correct. And here this in passive case also this is not correct. So whatever I have shown in the previous case, those are correct figures. So the figure here you can see. So the figure should have the slip lines or the failure lines like this. It's not like this. Got it? So whatever you're verifying as just if you see the textbook. So if any textbook is containing this type of figures, please ignore that. Okay. So this is the pattern of failure lines. Okay. Then just you can see, just I have written the passive earth pressure case, all those things. You can refer it later. Already we have discussed this. And these are expressions, whatever sigma 1 equal to sigma 3, these expressions given are based on the assumptions which we have discussed in the previous class. Okay. Suppose if you have the C value also. So in the Kp and Ka we have seen for C is equal to 0 case. If you have C equal to some value somehow. Okay, I'll increase the size weight. So already we have seen this strength envelope. Already we have seen, and then if you want to get this failure line, so just to search for that. For this one, just already we have, I am mentioning the failure conditions here. This is, so with some angle, that is 45 plus 5 by 2. Theta is 45 plus 5 by 2 in case of active earth pressure. So if you draw a line passing through the major principal stress point with 45 plus 5 by 2. So here you can see 45 plus 5 by 2. It may touch the Mohr circle at one point. The intersection point, if you consider and if you draw one tangent to this intersection point, then you may get C intercept here, y-axis intercept, which is nothing but C, and the angle of the slope of this line, which is represented as angle of internal friction. So you can calculate C and phi by knowing only one value also. That's what I want to say. So in shear strength parameters calculation, you are going to calculate using 3 observations. So here it's not that much required. So if you know that principal stress and principal stresses, then if you know the active and passive case, then you can able to draw the Mohr circle. From this Mohr circle, you can able to draw one line with an angle of 45 plus 5 by 2, and then you can able to get C and phi values. So that is one procedure. Suppose if you have the passive earth pressure. So if you have passive earth pressure, you need to draw theta, which is nothing but 45 minus 5 by 2. You can see here. So 45 minus 5 by 2 for this passive case. Okay, so that is not given here. Anyway, I'll go back. Wait. I have figure here. You should draw the graph. You should draw the line. So from this point, that is sigma 1 point. So 45 minus 5 by 2 is the theta angle here. So you draw the line with this angle. And then you can get intersection point and draw tangent to that intersection point, and you can able to get C and phi values. So this is for passive case. Okay. Now, if you have a C value also, so in the previous case, just we can able to say that as C and phi both are there. But here, in order to represent the active earth pressure along the length of the retaining wall, initially, if you see the retaining wall concept here, again I need to go back. So here, if you know this retaining wall, so retaining wall is experiencing some wall burden pressure and the soil over here. So due to the soil, the lateral earth pressure is 0 at the ground level, and it will be increasing up to the bottom of the retaining wall, which is nothing but K naught into gamma into H. So if C is equal to 0, K naught into gamma into H. So K naught is lateral earth pressure coefficient in case of rest condition. In case of active pressure condition, K naught can be taken as Ka, and in case of passive earth pressure, that is Kp. So K or Kp or K naught into gamma H is the lateral earth pressure due to the soil. And if you have any extra pressure or overburden, the surcharge pressure here, so then that surcharge pressure can be taken as constant throughout the length of the retaining wall. So that's why just you can see here. So Q multiplied by K naught. If it is active, Ka multiplied by Q. If it is passive pressure, Kp multiplied by Q. So that you can calculate from this. So already we have discussed that. So here what we are going to discuss is, suppose if you have the C5 soils. So when you have C5 soils, if you want to calculate the active earth pressure, so that active earth pressure is nothing but sigma. Here, this is the expression from the shear strength values. Sigma 1 equal to sigma 3, and sigma 1 we are considering at sigma V, and sigma 3 is sigma A. So in order to represent the active case, sigma A we are representing, which is equal, sigma A prime into tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. So here sigma A is equal to, the expression is just by rearranging the terms, we may get this expression. So sigma A, sigma V divided by this tan square 45 plus 5 by 2 minus 2c tan 45 plus 5 by 2 divided by tan square 45 plus 5 by 2. So once you have the values, then if you cancel this tan value, so then you are going to get 1 by tan 45 plus 5 by 2. So then if you bring that component to the numerator, then it would be 45 minus 5 by 2 in case of tan square and tan. Okay. So this is the expression, and whenever you have rest condition, this sigma A is equal to 0. So when if sigma A is equal to 0 means, so gamma into this Z, sigma V is gamma Z. So up to some extent, so you can represent this sigma, ZC, so which is indicating the critical depth. How it will be, we'll see later. Multiplied by Ka minus 2c root Ka. Just after rearranging these terms, then we'll get this. So tan square 45 minus 5 by 2 can be taken as Ka, and this is root Ka, and 2c is same as the previous expression, and sigma V is gamma into Z, which is represented here ZC. Why we are representing that as ZC means, so here if you draw this curve, if you draw the lateral earth pressure, so initially if you consider when Z is equal to 0, so this term will become 0. So otherwise I'll take this one. Sigma A is equal to this expression. If you take sigma V is gamma into ZC, and this is the one. Okay. So whenever you have this 0, wait 1 minute. Sigma A, or just you can say the lateral earth pressure is 0, where the lateral earth pressure will be 0, that you can obtain from this. So if Z is equal to, if you are taking Z value at ground level, if Z is equal to 0, that means ZC is equal to 0, and the lateral earth pressure is minus 2c under root Ka. So if you take this expression, so this term, first term will become 0. Then lateral earth pressure at Z is equal to 0, that is at ground level. So then you will be left with minus 2c tan 45 minus 5 by 2, that is minus 2c root Ka. So that is given here, minus 2c root Ka. Minus is not represented because you are representing the lateral earth pressure in picture form or in figure. Okay. So once you have this, then when it would be 0, so lateral earth pressure will be 0 at some point, because here you have minus and this is 1 plus. So here you can see. So due to the soil, just if C is not considered, then sigma V, that is Ka into sigma V, that is Ka into gamma Z. So along the length of the retaining wall, and due to the cohesion, this value is, so here these two terms are written so separately. So what we want to see here in the resultant figure, we are combining this effect. So initially Z is equal to 0, so you may get minus value. If Z is equal to H, so you can get this as gamma H into Ka minus 2c into root Ka. So that's what here you can see. Sigma V is nothing but here gamma into H into Ka. Sigma V is gamma into H, and this lateral pressure is sigma V into Ka minus 2c into root Ka. Okay. So this is the